Hello, this is my English speaking practice, and I'm talking about my tech study. And today I haven't decided the topics. Yeah, so I'm what to learn. For example, this is a website for technology. So what should I learn about? I learn tech so that I can pass the tech interview. So I want to learn something related with it. Yeah, and I belong to Linux profile, so the OS operating system is good for me. I've learned consistent hashing and the architecture of distributed key value stores. Today I'm gonna study AWS. For example, networking. Security storage. Fleets. What is fleets? Fleet. Oh, what do you mean? Okay, I got the concept. So, for example, EC2 fleet, you need multiple instances with either single configuration or mixed configuration. You wanna self-manage your instance lifecycle. If you don't need all scaling, recommend that you use an instant fleet. Create an instant fleet of both on-demand instances and spot instances in a single operation with multiple launch specifications that vary by the instance type, AMI, availability zone, or subnet. The spot instance allocation strategy defaults to lowest price per unit, but we recommend changing it to price capacity. As a general best practice, we recommend launching fleets of spot and on-demand instances with Amazon EC2 or scaling because it provides additional features you can use to manage your fleet. The list of additional features includes automatic health check replacements for both spot and on-demand instances, application-based health checks, and integration with elastic load balancing to ensure an even distribution of application traffic to your healthy instances. You can also use auto-scaling groups when you use AWS services such as Amazon ECS, Amazon EKS, self-managed node groups, and Amazon VPC Lattice. For more information, see the Amazon EC2 auto-scaling user guide. If you can't use Amazon EC2 auto-scaling, then you might consider using EC2 Fleet or Spot Fleet. EC2 Fleet and Spot Fleet offer the same core functionality. However, EC2 Fleet is only available using a command line and does not provide console support. Spot Fleet provides console support but is based on legacy API with no planned investment. Use the following table to determine which fleet method to use. So basically, Amazon recommends the auto-scaling. You need multiple instances with either a single configuration or mixed configuration. You want to automate the lifecycle management of your instances. Create an auto-scaling group that manages the lifecycle of your instances while maintaining the desired number of instances. Supports horizontal scaling, adding more instances between specified minimum and maximum limits. So this is same, and you want self-manage your instance lifecycle. I see. And if you don't need to auto-scaling, we recommend that you use it. Okay. Okay. When planning your EC2 fleet or spot fleet, we recommend that you consider the following options when deciding how to configure your fleet. To start using the EC2 fleet, create a request that includes the total target capacity, on-demand capacity, spot capacity, and launch template specifying the configuration for the instance in fleet. You can optionally specify additional parameters or let the fleet use default values. You can also tag the fleet request and its instances and volumes when you create a fleet. The fleet launches on-demand instances when there is available capacity, and launches spot instances when your maximum price exceeds the spot price and capacity is Okay. I want to learn about the network layer second data link layer that is related with network interfaces. An elastic network interface is a logical networking component in a VPC that represents a virtual network card. You can create and configure network interfaces and attach them to instances that you launch in the same availability zone. The attributes of a network interface for it as it's attached or detached from an instance and retouched to another instance. When you move a network interface from one instance to another, network traffic is redirected from the original instance to a new instance. Note that this AWS resource is referred to as a network interface in the AWS Management Console and the Amazon EC2 API. Therefore, we use network interface in this documentation instead of elastic network interface. The term network interface in this documentation always means elastic network interface. Okay. Our network interface can include the following attributes: a primary private IPv4 address from the IPv4 address range of your subnet, a primary IPv6 address from the IPv6 address range of your subnet, secondary private IPv4 addresses from the IPv4 address range of your subnet, one elastic IP address, IPv4 for each private IPv4 address, one public IPv4 address, secondary IPv6 addresses, security groups, MAC address, source destination check flag, description. So that is about IP layer and also data link layer, because that has a MAC address. You can enable a VPC flow log on your network interface to capture information about the traffic going to and from our network interface. After you create a flow log, you can view and retrieve its data in Amazon CloudWatch log. For more information, see VPC flow logs in the Amazon VPC user guide. The concept. The following are important concepts to understand as you get started using network interfaces. Primary network interface. Each instance has a default network interface called the primary network interface. You cannot detach a primary network interface from an instance. Secondary network interfaces. You can create and attach secondary network interfaces to your instance. The maximum number of network interfaces varies by instance type. For more information, see maximum IP addresses per network interface. IPv4 addresses for network interfaces. When you launch an EC2 instance into an IPv4 only or dual stack subnet, the instance receives a primary private IP address from the IPv4 address range of the subnet. You can also specify additional private IPv4 addresses known as secondary private IPv4 addresses. Unlike primary private IP addresses, secondary private IP addresses can be reassigned from one instance to another. Dual stack subnet means IPv4 and v6. The instance receives a primary private IP. Specify. You can specify additional private. Okay. And primary private IP addresses cannot be reassigned from one. Only secondary private IP addresses can be reassigned from one instance to another. Okay. And all subnets have a modifiable attribute that determines whether a network interface is created in the subnet. Are assigned a public IPv4 address. For more information, see subnet settings in Amazon VPC. When you launch an instance, the IP address is assigned to the primary network interface. If you specify an existing network interface as the primary network interface, when you launch an instance, the public IPv4 address is determined by this network interface. All subnets have a modifiable attribute that determines whether network created in the subnet are assigned. Okay, gotcha. When you create a network interface, it inherits the public IPv4 addressing attribute from the subnet. If you later modify the public IPv4 addressing attribute of the subnet, the network interface keeps the settings that was in effect when it was created. When you create a network interface, it inherits the public IPv4 addressing attribute from the subnet. If you later modify the public IPv4 addressing attribute of the subnet, the network interface keeps the settings that was in effect when it was created. Keeps the settings. Okay. When we release the public IP address when the instance is stopped, hibernated or terminated, we assign a new public IP address when you stopped or hibernated instance, unless it has a secondary network interface or secondary primary IP address that is associated with an elastic IP address. You can associate an elastic IP address with one of the private IPv4 addresses for the network interface. Hmm. 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 This is this is difficult to understand even in Japanese. Hmm. Okay. Okay. Network cards. Most instance types support one network card. Instance types that support multiple network cards provide higher network performance, including bandwidth capabilities above 100 gigabit per second and improved packet rate performance. When you attach a network interface to an instance that supports multiple network cards, you can select the network card for the network interface. The primary network interface must be assigned to network card index 0. EFA and EFA only network interfaces count as a network interface. You can assign only one EFA or EFA only network interface per network card. The primary network interface can be an EFA only network interface. The following instance types support multiple network cards. For more information about the number of network interfaces that an instance type supports, see maximum IP addresses per network interface. So network interface and network cards are different concepts. So the available number of network cards are defined by instance type. So a network interface is a AWS resource. So that is not physical one. So that is a abstract concept. But the network card means I feel like network interface card that is we call NIC or like that. So I think this is close to physical hardware. IP addresses create a network interface attachment. What is a EFA? Oh, fabric adapter. Placement group. Instance topology. Describing your instance topology provides a hierarchical view of the relative proximity between your Amazon EC2 instances. You can use this information to manage high-performance computing and machine learning compute infrastructure at scale while optimizing job placement. High-performance computing and machine learning jobs are sensitive to latency and throughput. You can use the instance topology to detect the location of your instances and then use this information to optimize HPC and ML jobs by running them on instances that are physically closer to each other. You can use instance topology to detect the location of your existing instances, but you can't use it to choose to launch a new instance physically close to an existing instance. To influence instance placement, you can create capacity reservations in cluster placement groups. Okay, I get the overview. Instance topology views are only available for instances in the running state, and each instance topology view is unique per account. The AWS Management Console does not support viewing this information instance topology. So there is an API for describing instance topology. Okay, so graph shows that the server or instance 1 and instance 2 is so close, and on the other hand instance 4 is far from instance 1 and 2 and 3 because so instance 1 connects to the network node 4 in layer 3. When considering the proximity of instance 1, 2, and 3, instance 1 and 2 are closer to each other because they connect to the same network node, while instance 3 is farther away because it connects to a different network node. NN5. Okay. As a general rule, if the network node connects to any two instances in the same, these instances are physically close to each other, or is the case with instance 1 and 2. Furthermore, the fewer the number of hops between network nodes, the closer to the instances are to each other. For example, instances 1 and 3 have fewer hops to a common network node than they have to the network node they have in common is instance 4, and they are closer to each other than they are to instance 4. That makes sense. Okay, I didn't know these features. Placement group. To meet the needs of your workload, you can launch a group of interdependent cluster partition spread. Amazon EC2 provides enhanced networking capabilities through the Elastic Network Adapter (ENA). To use enhanced networking, you must use an AMI that includes the required ENA driver or manually install it. Then you can enable ENA support on your instance. To review release notes or install instructions for an ENA driver, see the tab that matches your instance operating system platform. Okay. I learned about EC2. But I should have decided the topic, a specific topic. Okay, right now I'm going to plan or think about the topics I will learn. Yeah, I have ideas about what to learn because I'm interested in technologies, so I have some topics to learn. For example, distributed system. for example, determinist Bloom filter Mark III. Cache. So data structure cache. Cache memory because for example, page cache. Page cache. Yeah. In other words, performance metrics or performance. So in order to optimize it, you should know about the fundamental. I see. So, file systems. Or Memory, so in terms of development, um, design or before design, requirements. For example, no, I'm not organized. My thoughts is not organized. Oh, this is good. This is good. Coding interview preparation, system design interview preparation, behavior interview preparation. So this is the coding. What? So my strength is coding coding, system design, backend or distributed system design, API system design. Performance anti-patterns. I'm interested in these kind of problems. Cloud design patterns. This is important because I'm work with cloud and design and implementation. This is nice. System design. Products and systems. Okay, I'm gonna learn about this kind of system designs or kind of problems. But I also have to learn about OS or such a micro problems. I don't know how to say.日本語で喋るんですが、間違った。 日本語で喋るのですが、今は、学んでいくトピックについて考えています。で、自分の興味のある分野としては、システムデザインとか分散システムとか、そういう作るシステム全体のアーキテクチャとか、そういうものの仕組みについても興味があって、そこもホットなのでやっていきたいとは思っている。ただ同時に、もう少し小さなというか細かな部分、 OS の中の話、仕組みとかねもうやらないといけないから、そこら辺の優先順位というか、そこら辺をこうやっていく必要があって、別々ではないから、一緒にやれたらいいとは思っているんだけど、でも別々に考えた方がうまくいく場合の方が多そうっていう気がしていて、何をやろうかなっていう感じですね。Okay, I'm speaking in Japanese right now, but I'm thinking about the topics I want to study. I'm interested in areas like system design, distributed systems, and mechanisms behind mechanisms.
Mechanism.
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 Mechanism. Mechanism. Mechanisms. Mechanisms. And the mechanisms behind during large-scale system architectures. Since those are hot topics, I'd like to dive into them. At the same time, I also feel I need to work on the smaller, more detailed aspects. Aspects. More detailed aspects like the inner workings of operating systems. I think it's important to study those two. These two areas are and completely separate, so ideally I'd like to tackle them together. That said, I also feel that if I treat them as separate, my broadcasting might go more smoothly. So right now I'm still figuring out what exactly I should focus on. I wanted to say like this. What was difficult? I'm speaking in Japanese right now, okay, but I'm thinking about the topics I want to study. Yeah, I'm interested in areas like system design, distributed systems, and the mechanisms behind building large-scale architectures. This is a phrase that I cannot come up with. The mechanisms behind building large-scale system architectures. Since those are hot topics, I'd like to dive into them. At the same time, I also feel I needed to work on the smaller, more detailed aspects. Okay. Phrases, mechanisms behind building large. Mechanisms. The mechanisms behind building large-scale system architectures, more detailed aspects. Inner workings of operating systems. I think it's important to study these two areas and completely separate, so ideally I'd like to tackle them together. Work on them together like that. Yeah. That said, I also feel that if I treat them as separate, my broadcasting might go more smoothly. So right now I'm still figuring out what exactly何をやろうかなという感じですね。I'm still figuring out what exactly I should focus on. I'm still figuring out what exactly I should focus on. Okay. Good. And system design cheat sheet. OS backend or web development, language DevOps, computer science, cybersecurity, operating systems, networking knowledge. Cybersecurity feels like more professional, so That's too much. Computer science is computer science. OS, where is the OS, operating system? AWS is back end. It's fun to see the roadmaps. But this is not study. Cybersecurity is interesting. Oh, Linux is here. This is not bad. Yeah, this is fundamental, so it's good. It's good as my English speaking practice. Free resources. For example, share and other basics. What is redirects? Standard in out, standard error. Okay. Mm-mm-mm. Super user file permissions, archiving and compressing. Just explain the usage of command. So this is not fun to me. So I hope this study is fun to me. So I want to learn what I'm interested in. So I don't want to know the usage or way to use of something. I want to know the inner working. For example, net filter. What is this? IP tables, packet filtering. Or DHCP. Okay, this is, but why I couldn't find the Linux here? Oh, there is. I didn't find it. So system design is attracting me. I've learned CAP theorem, weak consistency, eventual consistency, strong consistency, and failover and replication. Background jobs. Load balancing. And caching. Performance anti-patterns. Synchronous I/O. What synchronous I/O antipatterns? Blocking the calling thread while I/O completes can reduce performance and affect particle scalability. Synchronous I/O operation blocks the calling thread while the I/O completes. The calling thread enters a wait state and is unable to perform useful work during this interval, wasting processing the resources. Yeah, I see. Common examples of I/O include retrieving or persisting data to a database or any type of persistent storage. This antipattern typically occurs because it appears to be most intuitive way to perform an operation. An application requires a response from a request. The application uses a library that only provides synchronous method for I/O. An external library performs synchronous I/O operations internally. A single synchronous I/O call can block an entire call chain. Yeah, that's right. The following code uploads a file to Azure Blob Storage. There are two places where the code blocks waiting for synchronous I/O: the create if not exist method and the upload from stream. I/O operations that are expected to be very short-lived and are unlikely to cause contention might be more performant as synchronous operations. As an example might be reading small files on a solid-state drive, and the overhead of dispatching a task to another thread, synchronizing with that thread when the task completes might outweigh the benefits of asynchronous I/O. However, these cases are relatively rare, and most I/O operations should be done asynchronously. Okay. So if you use the asynchronous I/O, there is overhead, like dispatching a task to another thread and synchronizing with that thread when the task completes. But these cases are relatively rare. Okay. And improving I/O performance may cause other parts of the system to become bottlenecks. For example, unblocking threads might result in a higher volume of concurrent requests to share resources, leading in turn to resource starvation or throttling. If that becomes a problem, you might need to scale the number of web servers or partition data stores to reduce contention. So in this example, if you use the asynchronous I/O, it causes a high volume of concurrent requests, and leading in turn to resource starvation or throttling. In this case, what is a resource? Shared resources is like a SSD or like that. Okay. Okay. What to study? I'm getting less motivated. I need to be more fluent, and so I have to practice speaking English, and in order to keep practicing, I want to work on the interesting topics. Hmm. Uh, how to improve my English. Hmm. Let's decide the topics I want to explain fluently. Okay. And then just practice it. Yeah. So, I want to explain some mechanisms. Yeah, consistent hashing is a good example. This blog series creates a small operating system in Rust programming language. Each post is a small tutorial and include all need codes so you can follow. Okay. Ah, this is nice. A little bit old, this article. I think this is nice. And I also want to study about the P2P networking. I want to study about P2P network because I'm gonna create a mobile game and it's an online game, so I plan to use the Unity Relay service, but it's costly, so in the future I want to implement a relay server by myself in order to reduce the cost. So I want to know the theory for peer-to-peer. Not traversal, hole punching. Most devices are behind, not firewalls. To connect peers directly, you need techniques like UDP hole punching, sometimes helped by STAN servers, relay fallbacks. If hole punching fails, a relay server forwards packets. This costs bandwidth on your side, which is why Unity charges. Who decide the truth of the game state? If for P2P, cheating is easier because each client has equal power. Often, one peer is selected as host. Common models for P2P games. Hmm. Traversal using relay around net. Serverless HTTP logic. So no raw UDP sockets. Okay. Okay. I see. Okay. Kotan. Kotan is a free open source implementation of Tarn and Stern server. to estimate the cost difference between Okay, I see. So if the bandwidth is tiny, I can continue to use Unity Relay. The two players connect directly to each other. Their packet never go through your relay server. Okay. But since most home mobile networks allow UDP hole punching, the majority of players will connect P2P successfully. That means your relay cost will be even lower than earlier estimates, because only the unlucky players behind strict nuts you will use your relay. Oh, I see. Okay, I've decided the topics to learn. Yeah, so I will learn about these topics from tomorrow. Thank you for watching. Bye.